Look at this. On the left, me awkwardly holding a doll. On the right, a clean, professional animation where the doll runs by itself. No green screens, no wires. Just the new Wan 2.2 AI workflow. I'm going to show you exactly how to turn your manual movements into independent character animation in 3 simple steps. First, look at the top left. We are selecting the Qwen model, specifically the Image Edit Plus 2511 20B version. This model is currently the best choice for image editing and repairs. To save time and avoid manual tuning for every single parameter, let's go to the Attention Mode section and load the Lightning Qwen Edit preset. Click Apply, and you'll see the sampler and inference steps below are automatically configured. This really speeds things up. Next, switch over to the Image Inpainting tab. I'm uploading our original image in the bottom left. You can see there's a hand holding the tag in the frame. As I've stressed before, a hand is a massive object that causes occlusion and flickering in the final video. So I'm using the brush to paint over the hand. We're creating a mask here to explicitly tell the AI, I do not want this object in my shot. With the mask ready, we need to give the AI a command. In the prompt box, I'm keeping it simple. Remove human hand. I'm also setting the denoising strength to 1. This tells the AI it has total freedom to completely redraw the masked area and erase the hand. For resolution, I'll set it to 720p to ensure we get a sharp result. Okay, the inference steps look good. Let's click Generate. Now the AI is using our mask and prompt to seamlessly erase that hand. We will do the cleanup for both start and end frames. We begin to create the video mask. There is a Motion Designer plugin for TTM, but we are not using it now. That plugin is for image to video. What we are doing here is video to video. So we will switch to the Video Mask Creator tab. Here in Step 1, we upload our actual source video. Then we move to Step 2, Add Masks. This is where we define the video mask. I click directly on the backpack and the toy to add positive points. The AI instantly highlights the object in blue. This tells the system, keep the motion of this object. I'm adding a few more points at the finger to ensure the entire plush is covered. That's why we want to film the original video with sticks, as large objects like hands are difficult to process. Once the selection is perfect, click Generate Video Matting on the right. The system processes the video frame by frame. And there we have it, the alpha mask output. The subject is white and the background is black. Finally, simply right-click this mask video and save it. We will use this later to drive our final generation. By now, you should have your clean background plate and your motion mask ready. Now it's time to put it all together. Let's look at the interface. Up at the very top, we have our model selection. We are using Wan 2.2. Now, you could manually tweak every single setting, but to save us some time and get a solid baseline immediately, I'm going to the Attention mode and loading the Lightning Wan 2.2 preset. First, check the box for Start Video with Image. I'm uploading our clean, fixed image here, the one where we painted out the hand earlier. This tells the AI, this is your ground truth. Start here. But here's a trick we're going to use today. We're also going to use the End Image slot. Next up is the Control Video slot. Now, you might be thinking, wait, why are we uploading the original video here? It has that giant hand in it that we're trying to remove. That is true, but we aren't using this video for its pixels. We're using it for its physics. We need the timing, the weight, and the trajectory of the plush toy from this footage. If we didn't put anything here, the AI would have to guess how a toy moves. By putting the original footage here, we give it a blueprint for motion. But to make sure that hand doesn't actually show up in the final render, we need our safety net, the video mask. Go ahead and upload that black and white mask video we created in the previous step. This essentially tells the AI, pay attention to the movement inside the white area, but ignore the rest. Let's move to the prompt. For video to video, you don't need to write a novel. Keep it super simple.
I'm just using a few words to describe the motion I want, like a plush run. The control video is doing the heavy lifting for the motion, so the text is just a gentle guide. Now, look at the number of frames slider. Here's a common misconception. People think they need to match this number exactly to their input video. Honestly, it does not really matter. As long as this number is set higher than your uploaded video's frame count, the AI is smart enough to automatically cut it. It'll just trim the generation to match the exact length of your original footage, so don't stress about counting frames manually. For shift scale, I'm using 3.0, and for the scheduler, I'm sticking with Euler. These control the vibe of the noise generation. Feel free to experiment here, but these are safe defaults. One critical detail before we get to the sliders, look at the negative prompt. I've specifically typed human hands here. Since our control video does have a hand in it, there's a risk the AI might try to reconstruct it. By putting this in the negative prompt, we're explicitly telling the model, I know you see a hand in the source, but do not generate it in the output. Finally, let's talk about the seed. Right now, I'm leaving it at -1, which stands for random, but here's the pro workflow. You keep it random while you're experimenting, but, and this is important, once you get a result where the movement is just right, you go to the history, copy that seed number, and paste it here. That locks the motion. Then you can increase the resolution to 1080p or tweak the prompt, and the movement will stay exactly the same. All right, that's the full setup. Let's hit Generate. With the start and end frames locked, that high denoising strength and the negative prompt guarding us, we should get a seamless, clean video.
Now we're going to dive deep into a specific Comfy UI workflow. This flow is actually based on a popular community version. Basically, this workflow utilizes the Wan2.2 model, specifically for video-to-video tasks. To keep things organized, I've broken this massive workflow down into two separate parts. Part 1 is the preparation stage. This is where we use Qwen for image editing and SAM3 or Segment Anything 3 for masking. Part 2 is the generation stage, where the actual Wan2.2 TTM model does the magic. Let's jump right into Part 1. First things first, we load our original video file. The workflow will automatically resize it and extract two specific frames, the start frame and the end frame. Now, pay close attention here because this is not fully automatic. There is a manual step you have to do or the flow will fail. When the workflow extracts those frames, you will see them in the Preview Image node. You need to verify them, and then, this is the important part, right-click on that preview image, select Copy, go over to the Load Image node for Qwen, and hit Ctrl-V to paste it in. You have to do this manual copy-paste action so the editing model knows exactly which image to work on. Once the image is loaded, right-click and select Edit Mask. This works just like the tool in Wan2GP. You paint over the object you want to remove, like in my example, I'm painting over this tag behind the plush toy. Then, in the text prompt, I simply type Remove Tag. Remember, you need to do this for both the start frame and the end frame to ensure your video loops cleanly. Let's talk about the masking tool used here, SAM3. In this workflow, SAM3 is used to create the dynamic video mask. However, I have to be honest with you, I don't love the user experience here compared to Wan2GP. In Wan2GP, when you add points for masking, you get real-time feedback. You see exactly what is being selected. In Comfy UI, it's a bit of a guessing game. You click to add points, but you don't see the mask until you actually run the workflow. You won't know if your mask is accurate until the render is finished. So my advice, don't add too many points at once. If you click too much, the result usually gets messy. If you find this frustrating, you can totally cheat. Just use Wan2GP or another tool to create your black and white mask video first, and then simply load that file into this workflow. It saves a lot of headache.
All right, once we have our cleaned up frames and our mask, we move to the main event, the Wan2.2 TTM workflow. This is a pretty standard setup. We connect our original video as the input, our cleaned up start and end frames, and the mask we just made. A quick note on resolution. You'll see a switch with 3 options. Option 1 is 480p, option 2 is 720p. If you choose either of these, the workflow ignores the custom height and width sliders below. Only if you choose option 3, which is custom, will those manual height and width sliders actually work. So keep that in mind if you're trying to set a specific aspect ratio. For the prompt, keep it simple. Since we are using a control video, you don't need a novel. Just use simple words to describe the motion, like a plush running. Now, here is my favorite tip for this workflow. This will save you hours of time. There's a node called Preview High Noise. In Wan2.2, the high noise phase determines the overall structure and motion trajectory of the video, while the low noise phase adds the details. This node lets you peek at the result halfway through generation. If you look at the high noise preview and the movement looks wrong, maybe the character is warping or the physics are off, cancel the generation immediately. Don't wait for it to finish. This fail-fast approach lets you iterate much quicker. Regarding the seed, start with it set to random. Run a few batches. Once you see a movement pattern you like in that high noise preview, grab that seed number, set the widget to fixed, and paste the number in. Now you can increase the resolution or tweak details while keeping that perfect motion locked in. Final thoughts on hardware? This Comfy UI workflow is powerful, but it is heavy. It eats VRAM for breakfast. To run this smoothly without crashing, I recommend at least 24 gigabytes of VRAM. Personally, I don't run this on my local machine. I use a cloud server. If you are a beginner or you have a standard gaming PC with 8 gigabytes or 12 gigabytes of VRAM, I strongly suggest sticking with the Wan2GP standalone software. It's much more optimized for local hardware. It might not be as flexible as Comfy UI, but it runs smoothly and gets the job done. I've dropped the link to this workflow in the comments below. It's a free resource from the community, so give it a try. Thanks for watching, and happy generating!